Okay, so here we have the same problem that I showed in a previous video. It's a statics problem. Again, we've got some kind of object hanging here. Okay, some kind of object hanging there, which is producing a 30 Newton weight on this cable or string. We've then got some kind of beam here, and it's attached to the wall. It can pivot, however, it's held in place by this metal cable or string or whatever it is there, okay, which is stopping this from pivoting around in the clockwise direction. Okay, so everything's been held static. This sign is not moving, the object's not moving. It's a statics problem, which means that there must be zero resultant force in total. So I showed you how to do this problem with a vector triangle. This time we're going to look at it by resolving forces. So we're going to try and work out what F1 and F2 are. F2 is the reaction force off the wall acting on this metal bar. F1 is the tension in this cable, and 30 newtons is the weight of this object. Right, so what we need to do here is, the thing is, this force is acting vertically, this one here is acting horizontally. So what we can do now is we can take this force here and we can split it, this vector, into horizontal and vertical components. So the vertical component will be in this direction like this. Okay, so there's your vertical component. And then the horizontal component, you can draw in a number of places, but you could draw it along the top here. And if you draw it on the top there, that's the horizontal component. This angle here is 90 degrees. And we know that this angle here is 20 degrees. You should know that from similar angles in GCSE. Okay, so that's 20 degrees there. So now that we've done that, we can work out the vertical component of F1. Okay, so this vertical component here is the opposite of that angle. F1 is the hypotenuse. So to work out this opposite here, we need to use sine theta. So the vertical component of F1, okay, is going to be sine 20 is equal to opposite over hypotenuse, and hypotenuse is F1. So the opposite is what we're trying to work out. So that's going to be equal to F1 sine 20, okay? So that's the vertical component of F1. Now, we know that the vertical component of F1 has to be equal and opposite to this 30 Newton force here, because this vertical component is acting upwards, this 30 Newton force is acting downwards, and there must be zero resultant force. So these must be equal and opposite. So another way of saying that is F1 sine 20, which is the vertical component of this force F1, minus 30 must equal 0 newtons. Okay, don't really need to write the newtons there. Now, if we consider the horizontal component now, of F1, okay, horizontally, this is the adjacent to this 20 degree angle, okay, and obviously F1, which is written in somewhat of an awkward place, so if I just move that to there, F1 is the hypotenuse, okay, so we've got adjacent and hypotenuse, so this time we're going to use cos theta, so cos of 20 is equal to the adjacent, which is our horizontal component of F1, divided by the hypotenuse, which is F1. So the adjacent, which is the thing we're looking for, is equal to F1 cos 20. Okay, so the vertical component of F1 is F1 sine 20, the horizontal component is F1 cos 20. Now the next step is, we know that horizontally, this force F2 is acting to the right, the horizontal component of F1 is acting to the left, and we know that they must be equal and opposite. They must cancel out. They must add up to 0, basically, okay? So what we can say is that F1 cos 20 take away F2 is going to equal 0, okay? So we know that. Right, so having done that, we can now work out the solution to this problem. So the first thing we can do is just solve this equation here. And this one's nice and easy to solve. So if I just draw a line there, and we'll solve this equation. F1 sine 20 equals 30. Just move that over there. And therefore F1 is equal to 30 over sine 20. And that will equal 87.7 newtons or 88 newtons. Okay, if we round it to two significant figures in line with this data. Then we can solve this equation now. So we know that basically if we take this onto the other side, we've got F1 cos 20 is equal to F2, and therefore F2 is equal to F1, which is 88 cos 20, which is going to give us our answer, which will come out as 82. Let me just check that for a second. So 88 cos 20. So it comes out as 82.69 newtons, which will round up to 83 newtons. Okay. Now, the other thing to think about here is we know that these two forces are opposite. I drew the horizontal component of F1 up here, but equally you could draw the horizontal component of F1 down here along this line. And then you can see that they are acting, one's acting this way, the horizontal component of F1 acting that way, F2 is acting that way, and they are equal and opposite. They cancel each other out. I should have said as well that if you use 87.7 here, this comes out as 82.4, I think. So let me just check that. 87.7 cos 20 comes out as, 82.4, which would then be 82. But in A-level questions, if you show your working, you will get all the marks anyway, but that would come out as 82.4 if you were to use, instead of 88 there, 87.7, okay? So just something to watch out for. And then obviously if you rounded that to two significant figures, you'd get 82 newtons. So a slight disparity there, but as long as you show your workings, the marker in your A-level exam would be able to figure that out, and they would give you the marks, okay?